All right, so for this section, we're going to go over section 4 in chapter 12, and we're going to talk about several methods that are used to develop short-term and long-term weather forecasts. The essential questions for this section include what information is on a basic surface weather chart, how do digital and analog forecasting differ, and what are problems associated with long-term forecasts. Vocab terms are here that you need to understand to be able to be successful in this section: station model, isobar, isotherm, digital forecast, and analog forecast. And we'll talk about those in this presentation. So first up is surface weather analyses. So this particular station model is a record of weather data for a particular site at a particular time. Meteorological symbols are used to represent weather data in a station model. So in your chapter review or in your guided notes, you're going to need to be able to read one of these. You're going to be able to need to pull data from one of these. I think specifically it talks about changes in barometric pressure, so you'd have to understand what this means. So right here how it says there's a change in barometric pressure of -12. What that's telling you is that 3 hours ago, the barometric pressure that we have now was 12 millibars higher, or 12/10 of a millibars higher. To plot data nationwide and globally, meteorologists use lines that connect points of equal or constant values. And so there's a few different types of these. We have isobars, we have isotherms, and we have contour lines. We have contour lines. So here's an example of isobars, and what this basically means is these different sections that are near this line are that pressure. And then the pressure changes in these different areas. You might have seen weather forecasts where they'll create these instead of isobars, they'll be isotherms, and they'll group together cities, for example, that have the same expected temperatures. So using isobars, isotherms, and station model data, meteorologists can analyze current weather conditions for a particular location. A digital forecast is created by applying physical principles and mathematics to atmospheric variables and then making a prediction about how these variables will change over time. So this contrasts to an analog forecast because, like I said, a digital forecast is more what the instruments are getting, and an analog forecast is more like a historical model. So in an analog forecast, this is based on a comparison of current weather patterns to similar weather patterns from the past. And so you can look into the past and you can look at different situations of what the weather conditions were, and you can make inferences based off of what happened in the past. Make predictions off of models, weather models. So those are the two types, digital and analog. Okay, we have short-term and we have long-term forecasts. When we're talking about short-term forecasts, these are going to be the most accurate, especially compared to long-term forecasts, because there's a lot less variables. You could probably imagine that as time goes on in the future, we're talking about what's happening tomorrow, that's short term, but if we're talking about what's happening in a month or in 2 months, that'd be considered a long-term forecast. Even a week in the future is starting to get on the long-term side of things. As time goes on, the number of variables that would influence the weather goes up exponentially. So short-term forecasts, the most accurate detailed forecasts are short-term because weather systems change directions, speeds, and intensities over time. And once they've changed over time, the new sets of variables are going to be very different over time, and they'll continue to be very different exponentially. And then, like I said, with long-term forecasts, it's nearly impossible for computers to model every variable. They can't anticipate every variable or map every variable. And by extension, it would be even harder for them to take the variable of the variable. Like, for example, if we're calculating the variables for tomorrow, and then we try to consider, well, if X happens, then we have a whole different set of variables than if Y happens tomorrow. Okay, like for example, if it rains tomorrow, that's going to change what happens the day after. But if it doesn't rain tomorrow, then what happens 2 days from now is going to be, dependent on what happens tomorrow. So I hope that makes sense. I hope you understand and can answer these 3 questions. Those are your vocabulary terms once again. Thanks for watching. Hope you learned something.